This lesson is on writing the equation of a conic given a graph. Quickly, I'll just put this on the screen. This is a summary of a lot of the things that you learned from the first few lectures of this series. One of the things that isn't on this chart is any sort of shift horizontally or vertically. So obviously, just for example, if we are taking a circle, we could have x minus h squared plus y minus k squared equals r squared, and that would account for horizontal and vertical shifts. So this chart doesn't really have any of that, but at least you can pause and come back to this at any time during this lecture if you need to see something. Okay, the first thing we will do is we will be given a graph of what appears to be a hyperbola, and we are going to write the equation of it. So it looks pretty clear that the center of this would be at 3, -4. And it appears to open where the x term would be first. So we will have x minus 3 squared minus, and it's going to be a minus because it's a hyperbola, y plus 4 squared equals 1. So our main objective now is to figure out what goes in the denominators, what goes as our major and minor axis, or our axis, our radius in the x direction, our radius in the y direction. It's really not that hard given a graph, because we can tell here that the x radius appears to be 2. So we will put 2 squared under the x, and that's a 4. And it appears that the y is 4, so that's 4 squared underneath that, and that gives us 16. Now, if we want to go back and do any of the other things that are required from a hyperbola, we can also do that just given the graph. So if it asks for where the foci are, or foci, or however you want to say it, we would figure out the length of this right triangle. You may have been taught to do 4 plus 16 and add the denominators in a hyperbola, but it's also the length of the hypotenuse of this right triangle. So that's 2 squared plus 4 squared, which is the square root of 20, or 2 square root of 5. So that is added in the x direction because the hyperbola opens in the x direction. So our foci would be there at 3 plus or minus 2 square root of 5, comma -4. So that's where those two are. The asymptotes would be, that's a really awful dotted line there. It's not even close to what it's supposed to look like. So our asymptotes, oh, I guess I can't go that far or my microphone's going to fall off. Our asymptotes look like this. And I'll see if I can do this with my left hand, since I can't even walk that far without the microphone falling off. So our asymptotes would have the equation y equals, y plus 4 equals plus or minus 2 times x minus 5. So our slope, obviously, we have two different possibilities, since there are two different asymptotes that govern how far the hyperbola can go. All right, secondly, if we are given an ellipse, the center of the ellipse appears to be at -1, 3. So we would have x plus 1 squared plus y plus 3 squared in the numerator equals 1. Now we just have to figure out what the denominator is. And obviously we're writing equations. So the main objective here is to write the equations that we have. All the other stuff is just extra things that I'm throwing in there for reminders and practice. But if the question asks us for equations, our answer would be whatever this is. Okay, so now what we're going to do is we're going to figure out what our x and y radii are. That's a length of 3. That's a length of 5. So the denominator of the x part is going to be 9 because 3 squared is 9. The denominator of the y part is 25 because 5 squared is 25. And finally, if we wanted to find the foci of this, we would, many of you were probably taught 25 minus 9, which is 16. Basically, we're finding where the focus is. Then we construct the hypotenuse of this right triangle to be equivalent to half the length of the major axis, so the major radius in this case, which is 5. So we have 3, 5, and then our objective is to figure out how long that part of our right triangle is. And obviously, we should know 3, 4, 5 right triangles. So our distance from the center to the focus in the y direction, because it's stretched kind of in the y direction, our distance to the focus is going to be 4. So that is distance up and down for the y value of 4. So -1, -1, and -1, 7 are our foci. Finally, if we are given a parabola here, we have, this appears to be a parabola opening where x is going to be the non-squared term. It also appears that we have 2, -3 as our vertex. So a is some value that we don't know times y plus 3 squared plus 2. Now our objective is to find a, because once we find a, then we have the equation, and our goal all along was just to find the equation. So the good news is they gave us another point. That point is -2.5 comma 0. So I'm going to substitute in -2.5 for x. So that's the same thing as -5/2. And I'm going to substitute in 0 for y. And now we just solve for a. So if we solve for a, subtracting 2 from both sides gives us -9/2. 3 squared is 9. Divide both sides by 9, we get a equals -1/2. So our final answer for the equation of the parabola is x equals -1/2 y plus 3 squared plus 2. So if you're given a parabola where they give you the vertex and another point, write the equation of the parabola with the vertex in it, and then substitute in the other point or plug in the other point, and then solve for a. Okay, so our objective there was to solve for a. This is our equation. Now notice that our a value is -1/2. So real quick, just a little mini lesson and a reminder, -1/2 is the same thing as 1/4p. So p is -1/2 if we solve this for p, which means that um, our distance from the vertex to the focus and the vertex to the directrix is going to be -1/2, and that'll be in the x direction because our parabola opens in the x direction. So really quick, that's a graph of the parabola where the focus and directrix are also put on it. And if we were given this, where it didn't exactly tell us another point, but maybe it told us the focus or the directrix, it would be an equivalent question to saying one of these two things. Find the collection of points equidistant from 1.5, comma -3, and the line x equals 2.5. Or find the parabola that has vertex at 2, -3, and focus at 1.5, comma -3. So we could this is a little foreshadowing for the next lesson in the series. We'll do a bunch of problems like this next in the series. But really briefly, I will explain this one. Find the parabola that has vertex at 2, -3 and focus at 1.5, comma -3. Well, if we can see that this distance is 1/2, and the focus is on the inside, that means our p-value is negative 1/2, which means that our a value, which is 1 over 4p, is going to be 1 over 4 times negative 1/2, which is negative 1/2. We can then write the equation as x, because it opens in the x direction, x equals negative 1/2, we got that from a, times y, sorry about that, y minus 2 squared minus 3. I wrote that backwards. Y plus 3 squared plus 2. So that's kind of doing it the other way. Hopefully this helps you figure out how to do some of these problems, and we will be back for the next lesson later.